Hydraulic jack. How it works. A hydraulic jack is a mechanical lifting device used to apply great forces or lift heavy loads. This jack uses hydraulic power. The most common form is a car jack or pedal jack, which lifts vehicles so that maintenance can be performed. The more than tenfold increase in force produced by the hydraulic jack is sustained by the hydraulic lever principle. Let's try to understand how a hydraulic jack works, taking the bottle jack as an example. Lever 1 is positioned in such a way that the arm between the pump's plunger and the axis is smaller than the arm between the axis and the handle to which the force is applied. In this case, the mechanical lever principle is utilized, which allows to magnify the applied force several times. With the help of a mechanical lever, a force is applied to the small piston, making it move downwards. The pressure under the piston will be calculated as the ratio of this force to the area of the surface of the piston. According to the laws of hydrostatics, the pressure applied to the surface of the liquid is transmitted equally in all directions to all points of this liquid. This means that the same pressure will act on the large piston. The pressure on the both pistons is the same, but the area of the surface of the larger piston is larger. Therefore, it can assume a larger force. The larger the area of piston 2 and the smaller the area of piston 1, the greater the amplification factor can be obtained by using the hydraulic lever. The total displacement of the large piston will depend on the volume of fluid displaced by the small piston. The area of the surface of the second piston is larger. Therefore, the distance it is displaced by will be less than the distance that the first piston was displaced by. It follows that the hydraulic lever allows you to increase the force you apply to it. But at the same time, the movement of the larger piston is very small. To move the large piston further, a new portion of the fluid is necessary. But where does one get it? Let us add a tank and 2 check valves to our device. The check valves allow fluid to flow in one direction and do not allow it to flow in the opposite direction. Now, when we pull the handle upwards, the small piston will move upwards as well. The volume of the space underneath will begin to increase and the pressure will drop. Valve 1 will let fluid out of the tank and into the space under the small piston. Valve 2 is installed in such a way that it does not allow fluid to flow out from its place under piston 2. When the small piston reaches the top, we will begin to put pressure on the lever again. Valve 1 will not let fluid into the tank, and the valve 2 will allow fluid from under the small piston to flow into the space under the large piston, which will move up a little more. This cycle can be repeated many times. The lever is moved up, and cavity under the pump's plunger is filled. The lever is moved down, and the liquid is forced out into the space under the large plunger. If the load needs to be lowered, the release valve is opened, and the large plunger moves downward under the effect of the load's mass, while the liquid from under it goes into the tank.